Hi, welcome to Finally Something New. Today we're going to learn about decomposing a fraction. And essentially it's basically taking a fraction and you're going to write it into a sum of multiple fractions. For example, we have 5/6 can be written as 1/2 plus 1/3. Now we're primarily going to work with linear factors today in the denominator. Changes when we have nonlinear factors, and that's going to be tomorrow's lesson. So in order to do this, we have this fraction, 4x minus 7 over x plus 2 times x minus 3. Now notice you want to have these factored. Now, that's going to become very important for us. And these are considered linear factors because the power on the x's is just 1. So first thing to do, step 1, we're going to write as a sum of fractions, one sum for each factor. There's two factors in the denominator. This is called decomposition. Now multiplicity becomes a problem. We'll talk about that in a little bit. So what they're basically saying is I want to write this as a sum of fractions with my x plus 2 and my x minus 3 in the denominator. Now, for each sum, what we're going to do, we're going to place an a, b, or c, and so on in the numerator. Now, I only have two sums, so I'm going to use an a and a b. Now, step 3, you can't see it down here, but it says to use the LCD to expand the basic equation. So we're going to use our LCD. Well, what is the LCD in this case? X plus 2, x minus 3. And we're going to multiply it just like we have done before. So we're going to multiply everything by the LCD. Well, over here, if I multiply by it, I'm going to get 4x minus 7 equal to, over here, the a, it has the x plus 2, so that's going to cancel. I'm left with x minus 3. The b, it has the x minus 3. It's going to be left with the x plus 2. Like so. Next, it says substitute zeros of the basic linear factors. So, for example, I want to look for the 0 of x minus 3, which is 3. I want the 0 for x plus 2, which is x equals negative 2. And we're going to use these to solve for a and b. So it's very simple. I look for the zeros. My first 0 comes from x minus 3. Set that equal to 0. X equals 3. What I'm going to do now is I'm going to substitute that 3 into my whole equation. Okay? So 0, 1. So if I substitute 3 in here, we get 12 minus 7 equals a. 3 minus 3 becomes 0 plus b, and 3 plus 2 is 5. And if you notice what happens, all the x's went away. The a becomes 0, and what we're left with is 5 equals 5b. So therefore, we know b must equal 1. Very easy to do. Now we have to solve for a. So we get my other 0. Well, the other 0 comes from the other one, x plus 2. Set that equal to 0, we get x equals negative 2. Do my substitution. This time if I plug in negative 2, we get negative 8 minus 7 equals a. This time it doesn't cancel. Negative 2 minus 3, negative 5. And here we get plus b, negative 2 plus 2, 0. The b just goes away. We like that. We get negative 15 equals negative 5a. A equals 3. And now we're ready to rewrite our fraction with our a and b. So we get 4x minus 7 over x plus 2, x minus 3. That could be written as a sum, remember a, 3 over x plus 2, plus b, b was 1, sorry about that, over x minus 3. So we rewrote this as a sum of two separate fractions right there. Decomposition, kind of like we do in chemistry. All right, let's take a look at example number 2 here. The next example. We do the same thing, okay? So for example number 2, we're going to do the exact same thing. I'm going to write this. I have two factors, so I need two fractions. Each one, x minus 3, x plus 2. Now I need an a above here and a b above there. And I just multiply by my LCD, which is the x minus 3, x plus 2. Basically, your LCD is this one right here. Shh. So if I multiply across, this just becomes x plus 7 equals a. The x minus 3 goes away, but I'm left with x plus 2. The b, it has the x plus 2, so it just needs the x minus 3, like so. And now I look for my zeros. My first 0 is x equals negative 2. And I just plug it into my new equation. This becomes negative 2 plus 7 equals, that just becomes 0a, plus, be careful, negative 5b. And you can probably do this. 5 equals negative 5b, b equals negative 1. Get the other 0. We get from here. X equals x minus 3. So that becomes x equals 3. There's my 0. That's how I get my 0. Plug in the 3. 3 plus 7 equals, this just becomes, ooh, look at that. 3 plus 2 becomes 5a. Plus 3 minus 3, 0b. b goes, bye-bye, b. All right, and what are we left with? You could probably do this in your head. That's 10, so a equals 2. And now we just write our equation. We're going to get 2 over x minus 3 plus b, which is negative 1 over x plus 2. Now we may want to rewrite that as x minus 3 minus 1 over x plus 2. Either one's acceptable. Now, why do we do this? We use this quite a bit in calculus when we get into integration techniques. So this is going to be a skill that you're going to need to be able to do. All right, so let's take a look at number 2, and I'll let you guys try one. So if you need to go back at any time, please do so, okay? This stuff is very easy to do. All right, for number 2, oh no, must factor, gotta factor, like an actor, driving a tractor. I can factor out an x, and I'm going to get x minus 4. So I got my 2 factors. These are linear factors. See, that's not a linear factor. That's a quadratic factor. Now, tomorrow we're going to take a look at what happens if we get quadratic and you can't factor it. That's when fun begins. But for right now, pretty easy. So I'm going to write this out. 3x minus 1 over x times x minus 4 equals 2 factors, 2 fractions. We get x, x minus 4, and a and b. Easy breezy. Multiply through by my LCD. Now hopefully you guys are kind of catching on to a pattern. That just goes away, so we're left with 3x minus 1 equals a. It has the x. What's it going to need? Oh yeah, the x minus 4. The b, it has the x minus 4, but what's it missing? It's x. Poor lonely b, dumped on Valentine's Day, misses its x. Find your zeros. X equals 4 from here. Plug it in. We get 12 minus 1 equals, 0a plus 4b. Ooh, 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 nasty. We're going to get a fraction. What's b going to equal? Hopefully I didn't do this one wrong. If not, I am sure I will hear about it. So we get b is 11 over 4. Get the other 0. X equals, that's easy, 0. Now we like 0. Why? Oh yeah, 0 minus 1, negative 1 equals, that becomes negative 4a plus 0b. Oh, look, another fraction. A equals 1/4. Now, it is more common to get fractions than non-fractions on these, so don't worry about that. So I'm going to write it up here because I ran out of room. Equals a, which is 1/4. And how I write that is I don't write 1/4 over x. That should just be crazy. I'm going to write that as 1 over 4x plus b was 11 over 4. Right? So I'm going to write that 11 over 4 times x minus 4. And there be our fraction. Okay? Another way you can write, we'll talk about that next year in calculus. So what I would like you guys to try is number 3. I will help you factor it. We're going to get x plus 2, x minus 1. Then go and try number 3 and maybe number 4. Okay, so try number 3 and 4 on your own. Okay, so if you need to, go back and try these again. Okay, and then go on to part 2. And on part 2, we're going to talk about multiplicity. Okay, that kind of changes the rules a little bit for us, but not too much. See you then.